Hello, welcome to another Great Car Basic training program. So today we're going to be using a serial ring to do serial communications, which basically means we're going to be doing bidirectional communication between the microcontroller and the PC terminal. So what does that look like in terms of where we are? We've gone through 10 videos. This is number 11, and we've set up the serial yesterday, but we're going to recreate the serial anyway today, and then we're going to tomorrow start to look at timers. I've got a 16F 18313. It's a very small chip, but we're doing quite a lot with it, and I've got it connected to a PIC kit 2. What does it look like in terms of the chip? It's an 8-pin chip. It's orientated around like it is in this middle diagram here. I'll just put my pen on if you don't mind. It's this orientation. This is pin 1 down here, and these are the pin numbers 1 through 8. So how are we connecting it up? We are connecting it up. We're having a PC terminal here, and it's going to send data down through this adapter, small USB adapter we discussed yesterday, on the transmit line into this port here. We're going to write a program inside of the little heart here, okay, and that is going to then, that's its heart, okay, all right. It's going to do some processing and very quickly send it back out on the transmit line or the RX line, and it's going to come down here, back through the adapter and back into the terminal. Now, it's hard to prove this to you, so I've got a little trick to show you later on, okay? But that's what we're going to be doing. We are essentially going to be sending data this way in, and then the data is going to come out back into the terminal. Very simple stuff. So what we're going to be doing is we're going to be creating a buffer, okay? And that buffer starts empty. Okay, so if you can look at the diagram in your own sweet time, the diagram itself puts data into the buffer, and those the items are added into the end of the buffer using a serial interrupt handler, which we'll have a look at briefly. So when the items arrive, the items are put into the buffer. So essentially, the first one goes into here, and it will be read from here as well. Then the next one, so if you go H, E, L, L, and O, we would then be reading them H, E, L, L, O. Meanwhile, the rest of the data is being put into the rest of the into the ring buffer. So the items are removed at step 3, and they're removed from the start of the buffer, and then the end of the buffer then moves around. If too many items, and that's a typo there, that should be TOO. If too many items are added to the buffer, the old ones are overwritten, but our microcontroller is extremely fast and we don't have that happen. Now, what have we got to do? We've got this board, and I will show you what I've done. I have removed these LEDs. I've removed those because I'm reusing some of the lines here for communications, because we have got the, let me just check. Yep. We've got the input here on this LED here, and we've got the output on this line here. I said port. So we're going to be doing the following. We're going to use the PPSTool to create our configuration for the transmit lines and the receive lines. We're going to pull some code from the help, and then we're going to send some data, and hopefully it will all work. I'm still looking for a TTL adapter, but I can't see one on the desk here. Okay, let's get cracking. Okay, so let's look at what we've got on the lab. Okay, you can see I have got 2 lines, as I said. One is the orange one, and one is the yellow one, and that is the transmit line and the receive line. And there's not a lot going on inside of the processor today. That's not what we're going to be seeing. We're going to be seeing the terminal software. So the terminal software looks like this. It's quite boring, I guess, in terms of we're going to send some data. But let's get into Zoom. Let's get into SynWrite and get cracking, okay? Let me just get caught up with you on the big screen. This is my screen. I'm going to put the chip into here. We've been doing this for the last couple of days, so we need to tell it what chip we're using. And then always use option explicit, because option that will ensure that you maintain your Variables. Right, select PPS icon. It will fire up the PPS tool. Let me switch to the PPS tool in the editor here. Here we go. So we've said this before. We're going to put the transmit on RA5. Now we've been using this down here. Look, transmit is here, and we've been using that before yesterday. So we select that, we put it in. We've never used an input, so we have to select the input, and we're using the RX receive, and we're going to attach that to RA2. And if you look at the little diagram here, you can see that that's gone green, meaning that I've got a pin on it. And now if I add that in, I can see it's that pin there. So my orientation on my video is correct. Copy that. Go back into SynWrite and paste the code in. So that sets up the serial for us, okay? Now we need another mandated, if you remember yesterday, we need some mandated constants, but we're just gonna pull the code in from the help, and it has all those mandates in for us, okay? So in the help here, I'm just gonna go to full screen. I'm gonna type in the word ring. You could type in serial, but type in ring, and it's the second item down, which is the serial ring buffer. And here it is. It says this demonstration demonstrates how to create a serial input ring buffer ring. The program receives a character into the buffer and sends it back. Try sending large volumes of characters, it says. It uses an interrupt routine, which we'll have a look at. So I'm just going to copy all the code, except for the chip at the top, because I've already got my chip. And then I'm going to go back into SynWrite, and I'm going to paste it in. Let's zoom in on SynWrite. I'm going to change nothing initially. I am just going to program it, okay? All right. I need to save it. I've already had a go at this morning, as you can tell. This is a bit more complicated, this one. All right, I haven't changed anything in here. I'm just going to program it up and see if it programs. Now, you didn't see it do its funky stuff there. So let's just program it again. Here we go. Great, it's programmed. Now we're going to go into the terminal software. The terminal looks like this. It's quite boring. I'm going to rescan and just make sure that I've got it connected to my terminal, COM26, and connect. I've typed in hello world in this interface here, and I'm just going to show you what it does, and then we'll get a look at how it works. Hello world, it says. Now you might think that that didn't come down from the computer, but the microcontroller, but trust me, it did. Okay, I'm going to prove that to you in a moment. Hello world, I can type in hello world as many times as I like. 0, 1, 2, 3, 4, 5, 6, 7, 8. Is that? I didn't miss anything out then. Now, how can I prove to you that it's working before I explain it? I'm going to change everything to uppercase, okay? And I can do that by adding an or statement here. Now, you wouldn't normally do this, right? But everything I'm going to type in that was in lowercase will be in uppercase, or the other way around. I think it's be lowercase. So let me just prove it to you before I code it in. Let's go back to the terminal for 5 seconds and just type in, get rid of this line here, all these numbers, and I am just going to clear that down, and I'm going to type in some uppercase and lowercase. Uppercase, this is lowercase, yeah? Comma. Yeah, you'll see the issue in a second. This is lowercase. Oh no, let me just put it all. That's uppercase, yeah. Oh, ever. So here we go. It goes in as uppercase and lowercase. Great. Now I'm going to do this, or I'm just going to reprogram it. I've just added in my or statement and reprogrammed it. So in SynWrite, I've added in my here. I'll explain the code in a moment, I promise you. Now if I send the same thing, if I get into the right mode. I haven't done it right, have I? Oh, my code's wrong. Let's just try that again. I'll explain what I've done in a minute. If I do it correctly, for those who've noticed, I actually put an "and" in there in the source code. All I'm trying to do here is prove to you it's coming back from that controller. Okay. Now the microcontroller has just been programmed on my other screen here, and we'll see it come up, and it won't beep in my ear, which it did. Right, fine. Now this time, I'm sending the data. Struggling here this morning, and now it's all uppercase, lowercase. It's always lowercase. Now the reason for that is because if I go back to my source program, I added in this OR statement here, okay? And that OR statement meant that it's always in lowercase. So let me just get rid of that and I'll explain the code. All right, I'll just reprogram it. You can see it reprogramming it if you look at it like that. And then back into the terminal, and then we'll just send some more characters just to prove it all. It's all very happy. And now it's back to the right case. Now, we go through the code, see how it's working. It's pretty simple stuff, okay? Well, we're not interested in the PPS and above because we've done that automatically. We're setting the baud rate. This is a mandated constant that we need to put in to make the serial work. We declare some variables, and we declare our ring buffer. And our buffer is only 8 bytes. You could make that as big as you like, but just don't go crazy. I think it might moan at 256 bytes, but you know, it's pretty hard to overflow it, as I'll explain to you. There's a constant here which is actually called a macro. This is a macro style, and essentially there are two variables running in here. One's called next in and next out, and when they're not equal, we know we've got data in the buffer. We're going to set up the we dimension the buffer, okay, and then we call we initialize the buffer ring, okay, and let me just show you how that works. We're going to go down. If we look on the editor, we can see there's some subroutines over here on the left here, and I'm going to go click on that, and it will take me to what happens in here. That's quite clever. I initialize some variables because my buffer is at 0, 0 to start with, and then I set up an interrupt. And depending what type of chip it is, it sets it up correctly. Now, I don't even know which one it's doing for this chip, to be quite frank. I'm not interested, because the moment it has data coming in, it calls a routine called read USART. Let's have a look at that. Read USART goes and gets some data from the serial port and puts it inside our buffer. And the rest of this code indexes the buffer by 1 byte when it receives something. So what we've seen is how we load in the buffer. We initialize it, and then we set up an interrupt. So when the data comes in, it gets put in the buffer, then it increments 1 line up. Well, then we've got send some stuff to the terminal, started, serial devices, blah, blah, blah. And look, you can send in just ASCII values to the terminal. You can send this via hsend, and that is carriage return line feed, and there's 3 of them. Right, the meat of the code is this loop here. It gets characters and sends them back. And how does it do that? It tests this little macro called BKB hit, and that was the macro up here that says, is there any data? If there is data in the buffer, you know, if these aren't equal, okay, I just send the character back, look, and it's called send the next character in the buffer exposed via the function bjetc back to the terminal. Send it back. So what goes on in bjetc? It's really simple. It takes a local copy of an index, and it essentially loads the buffer into the function called bjetc, and function returns a single value. It then looks after them, manages the buffer for you properly. So it indexes the buffer by moving the buffer pointer forward by 1. Then it sets a local variable to ensure that the buffer is maintained properly. So what we've got is a method called read USRT, which puts things into the buffer, and well, it's actually like binary get character is bgetc, binary get character, very nice. Essentially, you get one character out at a time, and if there's nothing in there, then this will not be set to true. And that is the code. If I recompile it, you'll see it compile it up. I'll go back into the terminal, and I'm going to type in some numbers in the terminal. Actually, what I could do is I'll send a file. How about that, yeah? I'll clear that down. I'll clear the terminal, and I'll send a file. How about that? Let's see if it works. I've not done this before, but let's send an even bigger file. Here's a batch file up. So rather than have me type it, I'm actually sending a file up, but that file is coming back from that terminal, from the microcontroller. Now, I can prove this to you, actual fact. If I go to the lab lot, you can't quite make it out there, but if I show you, that blue LED is telling me there's data coming in. If I connect up my red LED, an LED, let's put it in an LED. I don't know which colour was at the top. We'll think it was the green one, was it? Was it the green one? Where is it connected to? That's the big question. Yeah, don't be doing this live. I think it was the yellow one. Yeah, you shouldn't do this stuff live. Oh, it's a live video. Now, is that sending code out? No, I can't make it work. I'm not struggling. But the essential thing in here is that what we've got is a method to send code back, and it's built into it's built in. All we're using is a function called hserial_receive, and we're using a function to go and that reads the data in, and then we're sending the data back using hserial_send. And with that, we have bidirectional communications. So the job today was to show you how to do bidirectional sending of data, and I think we've done that. Okay. With that, we'll call it a wrap. Enjoy.